Hello community, so great that you are back. Today we have a brand new study published by Georgia Institute of Technology, and we look at its implementation and maybe its relevance here to the latest research by Apple on the illusion of AI thinking. Now get me wrong, I don't care if you call it thinking, reasoning, pattern matching, I have no philosophical background at all. I just want to know how I have to deal in coding, what data I have to provide that I achieve a performance by the AI system that I want. Call it thinking, reasoning, I don't care. I just want to know which modus operandi I have to apply. The rest is not of any importance to me. So now we increase the complexity. Apple only looked here at the reasoning AI model. Now, Georgia looks here and adds here a vision model. So we are talking now about a vision language model that is able to reason. So why should we stay with this simple complexity? Let's increase it here. So you know the holy grail of AI. We know large language model, great in-context learning capabilities. It makes them so powerful. I mean, it's one of the reasons why RAG is working at all and the new agentic RAG system are functioning. So this question has really some importance that is really much more is Apple right or not with its ideas. It is about how do we have to deal with our current AI pattern machines. Let's start. Now, naturally, the whole AI community assumes that if we go from language model to vision language model, this feature will hold. We will have a multimodal RAG system. Of course, what else? So let's call this in-context learning then Multimodal In-Context Learning, MM-ICL. And the idea is simple. Now we show the vision language model into training an image and a question. We provide an answer. And then we show it there's some more images of image question answer pairs. So few-shot learning is happening now in the AI system. And yeah, this should also happen now in vision learning system with multimodal in-context learning. And you might ask, hey, why should we care to validate this idea? Everybody assumes that, yeah, this is working. And forget about Apple. Come on, we are in AI hype. Everything is perfect. Now, you remember, if you have seen my video, the question is much deeper. It is more or less about the correct pattern matching. I don't care about reasoning or thinking, but what pattern matching do I have to apply to get the best results for the best performance? Because if multimodal in-context learning is real, it is a real game changer. Imagine medical image analysis. It would be so much easier. Or you just show here the latest financial graph data here to your AI system, Financial data interpretation. You just provided some historic data and it automatically learns. You don't have to start supervised fine-tuning, reinforcement learning, any form here of strange other training methodologies. It is just happening because multimodal in-context learning is real. And then there's the questions. But excuse me, are those vision language models truly learning the task for the example so I can just provide it? Or do I have to provide a particular pattern because they master here the art of mimicry. So they use here a clever pattern recognition system, a pattern prediction system that appears intelligent to us stupid humans. But how do I have to handle this AI pattern machine of mine? So let's answer this. Simple. We just modify the system till the patterns break. And then we see if there's a symmetry in the system, how this operates. So easy, let's destroy it. Now, simple experiment designed to test the true learning ability of vision learning models was done by Georgia Institute of Technology. And they said, we have our classical standard ICL setup and in distribution. So the demonstration examples or the few-shot examples for our multimodal in-context learning are drawn from the same dataset as the final query, and I'll show you the dataset in a second. Or we had out of distribution, and now it gets interesting. Because if something is out of distribution, we have a distribution shift, and this means, now we could see some glimpse of a generalization, or some call it the emergence of artificial intelligence. Great. So what we do, the demonstration examples are now from a different dataset than the query dataset. So the task is absolutely the same and the examples provided are the same. So we have now two different, if you want, primary datasets. The text vision Q&A and an OK vision Q&A. Where you find it easy. You find it on Hugging Face. Here it is, text vision question Q&A. What is the brand of the phone? You have here the image, you have here the image with, whatever. You have 45,000 rows. So great. Second is here, Allen Institute for Artificial Intelligence and Carnegie Mellon University. Okay. Visual question answering dataset on outside knowledge, about 14,000 open-ended questions, manually filtered, beautiful. Use it. What is the expected result? If we say, hey, everything is fine, no? AI is great, now it's intelligent, super intelligent, hyper intelligence. So if the model is truly learning the method for solving here a task, adding more correct example in our in-context learning, a few-shot demonstration, it should help, no? Or at least not diminish the performance. So let's do this test. We have an immediate result. Now look here at the left side. Either you go with either of these data sets, you have the same result. Yeah? So what we have. So we do this here, Georgia did it here for 4-shot, 8-shot, 16-shot, or 32-shot. And you would say, yeah, the more example I provide here, the better the performance, because now the system knows exactly what I want. And here they have the difference of out of distribution minus in distribution and accuracy. And you would expect at least 0. No? Out of distribution, it's the same kind of information. Eh? In distribution, almost identical. So the difference between almost identical should be close to 0. So damn, what is happening? Why we are here in the negative area? Why we say this is not as good? Why is the more examples we provide, the worse the performance gets? How is this possible? Well, we have the first indication that our belief is not correct. The system is doing something completely different. Have a look at the paper, it's really beautiful. Or let's look here at this example. And I like it if they provide here visual examples that you immediately see. Now you have here an image, beautiful, let's say a lot of Marvel comics. No? And then the question is easy. No? What company made most of these books? Now, we have different vision language model. And QN 2.5, vision language 3B instruct says Marvel. And the system tells correct. And then you go to another system, Open Flamingo, and it answers Marvel Comics. And this is the wrong answer. And I said, hey, wait a minute, this is nonsense, no? You know what happens? This is a single word matching the format of many visual question and answer datasets, and therefore it is marked as correct. But the probability that it is marked as correct because the format matches a single word format, because of that particular reason, there's a possibility it could be marked correct. Because look at the other one. Marvel Comics, I would say, hey, that's a better answer, at least an equal answer. But because the evaluation script was likely expecting here a single word or a simplified answer, it is marked as wrong. This is the analysis of Georgia. So you see, what is correct and what is incorrect is suddenly only determined by the format. How many words you answer, not about the content. And this is, let's call it a crucial flaw. So a significant part here of the performance gain seen in the ID setting might just be an illusion. Hey, great, we learned something about the performance of the AI system, and it really breaks a pattern. It breaks my expectation pattern because I saw those models are able to do this. And if you just add a word, I would say, hey, it should have the advanced model here understand that this is just another word, but the content is correct. And then to label it as incorrect, that's crazy. So the model isn't necessarily getting better at reasoning about the image. No, it's getting better at mimicking the answer format that the model expected from its training dataset. So yeah, this is great. No? So in the ID setting, more examples reinforce here the correct format, but not the correct solution. And in the OOD setting, we have a less reliable heuristic here, and the model struggles. No? And it struggles here in some crazy ways I'm going to show you later. So what is the proposed solution? Now that we understand we do have a problem also in the vision language reasoning model, now, Georgia said, hey, simple, no? Multimodal in-context learning with reasoning. We have huge reasoning model. We have chain of thought reasoning. We have sync and end of sync tokens. We have reflective tokens, self-reflective tokens. We have, I don't know, whatever. We have MCP. We have agentic RAG system. We have agent-to-agent protocols from Google. We have brand new embedding structures, embedding vector spaces. We have brand new re-ranker just published 2 days ago. Imagine all of this would be nonsense if the system would not be able to handle this. So the core idea, Georgia tells us here, is to enrich each demonstration example, its training example here for in-context learning, not just with the final answer, but think about chain of thought. We provide now a step-by-step rationale explaining how the answer was derived by the, let's say, reasoning model. So the old way in a standard MM-ICL is image, what is the color? Answer, red. Now, the new way is you just insert here the rationale from the AI system. No? And AI says, hey, I identified here the car in the image, and I observed that the primary color of this car is, let's say, red, and then therefore the answer to the query is red. Nice idea. We have reasoning models, so why not use this? Yeah? So by providing you as an additional information to in-context learning for multimodal task, we provide now, or just provide now the reasoning chain. This means we give now the vision language model a much stronger indicative signal, hoping now it will learn the methodology than just mimicking the output format. Yes, of course, in the old time we did not have this. We had a format mismatch. Everything was not so great. But now with this new method, we have now a new demo. No? We have now a new sequence. We have the image, we have the human query, the question, then we have a rationale by the reasoning model, and then we have an answer, and this will enable us, this new training data set will enable the model to learn. And then our vision language model is expected to generate here maybe even the rationale and the answer, and it will be perfect, it will be beautiful. They did some beautiful tests. I just give you here the result. Please read the study. There are tons and tons of numerical simulation and tests and everything waiting for you. Just give you here the result. If you do this here, comparison of inconsistent and consistent support query format for a vision language model reasoner, they say, yeah, so the structure of this prompt with the reasoning is important. But between you and me, I mean, they only found here in the best case possible 8% improvement. So, okay, we take the 8%. We do not question 8%, but just that you have a feeling we are sometimes at plus 1%, plus 0.5%, plus 1%, plus 1%, plus 4%, minus 0.12. So this is not really a solid foundation, but it's an indication. And now the moment comes and Georgia tells us, hey, now we do it. Now we know what is wrong. Now we optimize our prompt sequence. Now we add additional reasoning information. We do it now with newer models, you know. We go with a QN 2.5 vision language or an R1 induced vision language model. We go here with reason fine-tuned variants. We really go with something beautiful. Unfortunately, they only used the Gemini 2.0 and not the 2.5, but okay. Showed you the data set and reasoning intensive data set now, particularly interesting. And we vary the number of shots and the quality of the rationale and the example and everything. And we do the best that we can. And now we have it. That the verdict is the model still does not learn multimodal in-context learning. It is not happening. And the authors tell us, after setting up here the ideal condition for the learning, providing yes, the results were disappointing. And if the authors of a study tell you that the results were disappointing, you know what they want to tell you, né? Few-shot in-context learning of multimodal did not improve the performance over a zero-shot performance. The system, the vision language model, the reasoning model is not able to learn from the given examples. This has implications for multimodal RAG system and agentic RAG system and everything that is connected here in this area. You know it, you feel it. want to give you here the results and just want to tell you it is not as clear as formulated here by the authors. Because if I look here at all the different models and all the different beautifuls, and you see here zero shot and the best few shot I can provide, I colored here the zero shot. So you see immediately 4 different benchmarks here, the zero shot performance, and bold is the best one. So here, beautiful. Yeah, there's some outliers, but okay. Or you see 88.56 and identical 88.65, sorry, it's one below, 85.68, 85.68. And the difference, even if now the best view shot is better, look, it is 88.56 compared to 88.65. So this is a minor little difference. And even if you go, yes, science, you have a similar pattern. Although I have to tell you, for the Gemini Flash, this is from 88 zero shot to 89 best view shot. So there is at least a little tiny bit of improvement, but yeah, it should be so much more. So it's something is not working even with Gemini. Yeah, and even go to the best one. You see here, I think this is here the real significant one. Huh? This is an outlier 62 for the zero shot. And at least we have 64 for the best few shot optimization. But come on, 2 percentage points. This is not it. Something is happening. Yeah? And otherwise, you see here there's a lot of bold in the zero shot column. Let's come back to the authors, and the authors tell us these results suggest that the current vision language system and the reasoner system, the reasoning vision language model, can barely learn from demonstration data, few shot examples, even if they present example data that is informative, even with a chain of thought, even with a reasoning sequence, even with the perfect format. You remember what I told you about RAG and MCP protocols, client server and everything? So what we do if all this, what we're bringing back to the vision language model in our prompt, if you want, is ignored for the learning, is not there to improve the learning. And from RAG we learned, hey, wait a minute, we have to be real careful. We have to go with the best available data. So you have to use here the perfect rationals. And we will replace now all AI-generated synthetic pseudo-reasoning, no? With absolute pristine ground truth gold reasoning. So we optimize the reasoning sequences in all our training data set. And the result is no significant improvement. Have a look at the data. You see here, we are plus 0.04 or minus 0.9 or plus 0.0. So no, this is not it. No problem. And then you have an idea, say, hey, wait, we have to use smarter retrieval, no? We have to use the best retrieval agent, the most complicated here with the most self-reflection and MCP squared, I don't know, no? And they compared now random example selection to a really sophisticated multimodal retriever, the best we can have, decide to find now the most relevant example here in this external data soup, no? So the best order retriever here from RAG, no? It's an agent that has multiple agents, and guess what is the result? The smart retriever was often worse than any random selection of data. So if you look at the difference on the y-axis where we have the best multimodal retriever, the complex that you have, and you subtract a random one, and you go into minus, this means that a random one was better as your best multimodal retriever agent or whatever constellation you have. This is not a good sign. And if you go then with a chain of thought completely in the negative, you know, the smart retriever are just worse than a random selection. So this is not the way out. So what is the conclusion? I think the conclusion is we have to rethink the path forward in AI. We encounter problems we do not understand. We have tests that are indicative. Something is not working at all with reasoning. Call it thinking, call it pattern matching, pattern identification. I don't care. I just want to know, what do I have to do to make this system work? Now, the authors tell us current vision language model, even the large-scale state-of-the-art ones, are not effective multimodal in-context learner. Do not use them. They are sophisticated mimics that excel at zero-shot instruction following, but fail to really learn. The moment you go out of distribution, the moment you have a distribution shift to your training data set, they're gone. Even if you apply or you enrich here the information with step-by-step reasoning, chain of thought reasoning, higher complexity reasoning, added multi-image things, it is simply not giving you the performance that we are looking for. So great. Isn't this great? So here we have this beautiful paper, Georgia Institute of Technology, published today, June 9th, 2025, Mimicking or Reasoning, Rethinking Multimodal In-Context Learning in Vision Language Model. And if you want, the summary is, the paper suggests, or the author suggests here that the problem that we encounter is a fundamental one. It is not that it is just the format of a prompt. It is not a specific chain of thought reasoning missing. It is not that we have not enough data. It is not that we have not a high diversity of data. It is not about the complexity of the data stream, not of the data set. It is somewhere down fundamental. Great. And if you combine this with one of my last videos, I think 3 days ago, where we talked about here this collapse of AI reasoning by Apple, just understand that they were talking here about the strength and the limitation of the reasoning models. So they also encountered here under normal linguistic reasoning model problems. And now what we do with this paper, 4 days later, Georgia Institute of Technology, encounter problems. And they ask here more or less the same question. Is there really a learning happening? Is there really a reasoning, a glance of reasoning shining through here our vision language model? And they answer, no, we found not really a strong indicator for this. What we found it is mimicking patterns. I'm fine with this. Okay, let's mimic. But if the performance is not there, mimicking is not okay anymore. So how do I have to optimize the system that I get a better performance? And whatever you call it, reasoning, thinking, mimicking, pattern recognition, pattern generation, pattern simulation, go with it. But where's the performance? We are missing something significant. So, does this kind of confirm the insights from Apple? On a complete different level of complexity, if we go here for a reasoning language model to a vision language model, Georgia Tech Institute of Technology tells us, hey, we found that the reasoning part is missing. And in-context learning that works so great here in the language model is more or less missing in multimodal models. It is missing in our vision language models. So I think we have now a second indicator that we are not done yet. It is not at all perfect. There is a huge amount of work in front of us. So what is next? Well, of course, as a subscriber of my channel, you know next is my next video, yeah? And in my next video, I have a simple message. Forget in-context learning. Forget multimodal in-context learning. I have a much simpler question. If I have a language AI, LLM, and I have a vision AI system, and if I combine them, can they learn? I don't want to go with few short examples here just in the prompt. Can we train our vision language model for new downstream tasks in the normal way? From supervised fine-tuning to our classical repertoire of training those models. Does it really work? Or do we have indication that now that we know what we are looking for, that also the classical training collapses? Especially for the reasoning part, and we cannot train those models new reasoning abilities. Absolutely fascinating. If you would like maybe to see the next video, hey, why not subscribe? And I see you there.